everyone, what's up? So last video I just show you how to make a one LED and blinking at the same time. Every LEDs are blinking at the same time. So in this video tutorial I'm going to show you one LED blinking at a one time, and the difference between 1 and 2 is 1 second. Okay, so in this video tutorial I'm showing you how to make this circuit, how to make this program, and that I'm going to give you the assembly code, everything, and the source code, the project file, everything link in the description. You can download it, check it by yourself, and the hex file, everything is available. Okay,
when you open the QMU Vision, first step you need to create a new project. Okay, new project, and start it in a folder with a path which is has no space and special symbol, okay, in the path. So we'd better save it in F disk, okay, F disk, and Q, okay, lab 2. Yeah, it's already recording. Yeah, here. Okay, and now you need to select the device, the microcontroller, the model for the microcontroller. Okay, model for the microcontroller, and there. Actually, you can use the model microchip. Okay, because microchip also manufactured 51 series microcontroller. Okay, you can select 89 C51. Okay, C51. And when this information, this window comes out, you just select no. Okay, no. Now the project is created, and you can create a new file to save your assembly language. Okay, new file. So create and document a new file, save it. But remember that you need to save it as ASM file, assembly language file. Okay, that's red.asm. Okay, it's not .c. .c means the C file. Okay, this one is the assembly language file, so save it as ASM file. Okay, now you can see the highlight. Okay, highlight. This part, maybe you just directly keep it. Okay, in the interrupt chapter, I will introduce how to use it. Okay, here org00h means this line will be stored in this address, at this address in the program memory, the code memory. Okay, org means this line of program will be stored in the code memory at this address. Okay, and this one org0030h means this line or this part of program will be stored in the code memory from this address. Okay, so this one is not instruction, just directives to tell the assembler where to store your instruction. Okay, so this part, this is our, you can see that the first instruction has to be stored at this address. Okay, that's why we need to use org00h, because the first line of your program has to be stored at this address or stored from this address. Okay, RJMP main means jump to main. Okay, it's like a main function in C language. Okay, now we move FE to A. A is ACC, right? Okay, and the value is ACC is equal to F. F is 4 ones. Okay, E is 1110 in binary form. Okay, it's binary. Okay, binary. Now we copy the value of A to P0. Okay, P0. Just remember which part we used in lab 1. Which part? P1, part 1, or part 2, or part 0? P3, right? This part is P1. So we use P1, okay? So if you want to control the LED connected to P1, you need to move the value or copy the value to P1, okay? So we need to change P0 to P1, okay? And CPL means invert all the bits of A, right? So after that, after this, ACC is equal to 0, 0, 0, 0, 0, 0, 1. Invert all the bit, right? Okay, and call delay. Delay just call it to obtain a delay. Okay, delay subroutine. And then RJMP loop, go back to loop. Move A to P1 again. Now, what is the value for P1? For the initial value, A is FE, right? And you copy the value A to P1. P1 will be this one, right? And you spell A and call delay and go back to loop and copy A to P1 again. But now, because you invert all the bits of A, right? P1 should be equal to 0, 0, 0, 0, 0, 0, 0, 0, 1. Okay? Yeah. And call the delay, and then you invert all the bits of A. It should be 1, 1, 1, 1, 7 ones and 1, 0 again. Okay? That's why you can see the flashing of this LED, right? Because you change the value of P1.0, okay? The LSB is P1.0, okay? Because you send this value to P1, then the LSB is related to this bit. The LSB is related to P1.0, okay? So you can see that the value of P1.0 is changing from 1 to 0 and then 1, then 0, okay? This way, you can see the LED on and off, on and, okay? That's how this program works, okay?
So how it exit the loop? It's a loop.
Yeah, this is the dead loop.
Yeah.
No way to get out, okay?
Okay, this is a dead loop.
Unconditional jump. Okay, actually, all the program for microcontroller will be written in this way, dead loop.
Okay, let's continue.
Right. Okay, it's very simple, right? Just the several instructions. Okay, but this one is a delay function. We use every instruction will take some time when the CPU executed, right? So if you have many lines of many instructions executed, then you can obtain a delay. Okay, that's why we use a DJZ. Do you still remember what is a DJZ instruction? Decrease R6 by 1. If it's not 0, jump to this location, right? Dollar means the current line. So it will continue executing this line until R6 is 0. Okay, we know R6 is 250, right? So this line of program will be executed for 250 times. Then get out to execute this one. Okay, clear? After and go back to D1. You know, every time you decrease the R7 by 1, if it's not 0, it will jump to D1. Okay, D1 is this line and move 250 to R6. Okay, R6 is 250 again. Okay, so this line will be executed for another 250 times. Okay, do you know the meaning? Every time you decrease R7 by 1, this line will be executed for 250 times. So R7 is equal to 200. So this line will be executed for 200 times 250 times. Clear? It's a lot of instructions, so you can obtain the delay. Okay. Every time you write a subroutine, you need to use RET as the last instruction. Okay, and you have to use a label for the first line. Okay, remember that. Okay, then use call instruction to execute it. Just this is the assembly language for the arithmetic control. It's very simple, right? Now we need to compile it. Okay, compile it. Just build. Okay, here build. If there are some errors, it will be reported here. Okay, errors. You can check the error and to correct it. There is no error. Okay, actually there is something you need to do. Okay, you can check the folder. There is no any program, right? You create a new document and fill some instruction in it, but you haven't added to this project. Okay, so we need to right click the folder and add existing files to group. Okay, to this group, add existing files. Then you can select the ASM file. Okay, you can find that the file just created. Okay, now it's in a folder, right? It's here. You can build it, rebuild, because you already built it. The better rebuild it. Okay, 0 errors, 0 warnings. Okay, but we need hex file, right? Because the hex file is the one we download to our microcontroller. Okay, but now we didn't find it. You can check the folder. Okay, here, right? No hex file. Okay, no hex file, right? Actually, you need to do more. Okay, right click target one. Right click target one, and the options. Select options. Okay, you can check the output here. Output. Okay. And there is a checkbox here, right? Create a hex file. You need to check it. Okay. And okay. Rebuild it. Now you can see that creating hex file from objects folder. Okay. Now let's go to the objects folder. You can find the hex file, right? Let's go back to our design, and you can select the hex file. Okay. You just create it. Okay. Because it's equivalent to download your hex file to a hardware. Okay. Then you can run it. Can you see that? it works, okay? But if you do not have the hex file, it will not work.
It's like a software in hardware.
Yeah, but that software is downloaded to the, it's executed in the microcontroller, okay? Yeah. So it's working now, right? Now, if you want to have a more, we did, right? Copy. You can. Okay. Okay. Every time you just want one LED on, okay? Make all of them. Close to the. That's what we did last time, right? We connect 8 lights to P1. Okay, P1. So let's run it. Okay, and deposit. Can see that because we let's go back to our program, right? You can see that here. ACC is 7 ones and 1 0, right? So these 7 LEDs are on. Okay, this one is off. Okay, let's run it and pause it again. Okay, here. Okay, this one is 1. P1.0 is 1. Is 0. Okay, 0. P1.0 is 0. So this one is on, and all the other 7 are off. Okay, you can see some blocks at the pin. Okay, blue square means low level. Red square means hello. Okay, you can see that the symbol. When here is high level and here is low level, the LED will be on. Okay, but if because here is high level, if you have high level here, it will not be on. Okay, so that's why the other 7 LEDs are off. Okay, because here are high levels. Okay, clear? Now we need to change the program so that we can have a a water light. Okay, water light. How to do that? Every time you can only have one bit is 0, right? So actually there is one instruction off here. Okay. Right. Every time rotate left for 1 bit. So the 0 bit will move from RSB to the 2nd bit, right? Let's take a look. Rebuild it. Remember to rebuild it, okay? Now stop it and download your program. Okay. I see that a very easy change, right? So you can have, it's like if you do it very quickly, you can have a the lights at the riverside, right? You can see this kind of phenomena, or it looks cool, right? And you can change the delay. You can change the delay. For example, if we Okay, the delay is obtained by control the loops. Okay, the loops. If we deforestate and change it to 100, let's take a look. Okay, right, it should change. And you need to, no, you cannot have a. So we need to change this one to R5 because you cannot have two loops crossed, right? So R5 should be included by R7, D, G, and C. R7. If it's not 0, you need to jump to delay. Right? No. D0. Sorry, D0, right? Jump to D0. Okay? Let's take a look. Very slow, right? Too slow. Okay, I will change. Maybe R7 to be 20, okay? 20. It's an actual loop, okay? So it's 20 times of the original delay, okay? Right?
Yeah.
So after you can use, control a lot of lag to display a picture. Okay, if you have many LEDs, that's called LED matrix. Yeah. Okay, that's how our LED monitor right LED working. Okay, there are many dots, very small. Yeah. Okay, so that you cannot discriminate them. Yeah. One by one. And the shop they are clear. Yes. That's also clear. I have, it's already recorded, so you can follow my steps to finish this one. Okay? I will send you a lab report, and you should finish this one and send the report to me, okay? Before next class. Okay? Any questions?